In this video, we're going to be looking at the zeros of polynomials and how the multiplicity of those zeros affect the graph of the polynomial. Now, the zeros of a polynomial are also called roots, solutions, or x-intercepts, because they are where the graph intersects or touches the x-axis. Now, multiplicity is how many times a zero comes up, or a factor comes up in a polynomial. And I'll explain that in some of my problems down here. Now, if you're given a polynomial and you want to find what the zeros are, you want to start by factoring the polynomial. So in this case, we start by finding the greatest common factor, which in this case is going to be x, because every term has at least x to the first power. So I'm going to take that out from every term. When I say take it out, I mean I'm dividing every term by x, which leaves me with x squared minus 2x minus 15. Now, we have a quadratic expression, and when we talked about quadratics, we talked about how to factor those quadratic expressions. So in this one, I'm going to find two numbers that multiply to be negative 15, but will add to be negative 2. So numbers that multiply to be 15 are 3 and 5. If I make the 5 my negative, 3 times negative 5 gives me negative 15, but 3 plus negative 5 gives me negative 2. So I can write this as x times x plus 3 times x minus 5. And I cannot factor this any further. So the next thing you do is you go and take each factor, set them equal to 0. So the first factor is x. I set x equal to 0. X plus 3, set that equal to 0. And x minus 5, set that equal to 0. And then I solve each factor. Now for x equals 0, there's nothing to do, so that's just going to be 0. For the multiplicity, well, how many times does this factor occur? Well, x as a factor only occurs once, so the multiplicity is 1. And we'll talk about the effect in a moment. For x plus 3, set that equal to 0 and then solve for x. So I subtract 3 from both sides to get x equals negative 3, which means negative 3 is another 0 of the polynomial. And just like with the x plus 3 only occurs once. So multiplicity is 1. Then we have the x minus 5 set equal to 0. I add 5 to both sides to get x equals 5. So my third 0 in this one is 5. Multiplicity is 1. Now these all have the same multiplicity. Now your multiplicity basically describes the behavior of the graph at that location on the x-axis. And what's going to happen is either the graph is going to cross the x-axis at that location, or it's going to sort of bounce at that location. Now this one, you're not going to see any bounces. You'll see that in some other ones, but let's look at the graph of this. Now we can see that it crosses here, here, and here at negative 3, 0, and 5, just like what we have here. So the effect of the multiplicity on the graph is that it will cross the x-axis at those locations. And I can tell because the multiplicity of each of these is odd. So odd multiplicity causes the graph to cross the x-axis. Even means it kind of bounces. And again, I will show you what that looks like in a minute. So let's look at another one. This one here, again, you start off by taking out the GCF, which is x again. which leaves me with this. Okay. Now I take the 9 and find two numbers that multiply to be 9 but add to be -6. Well, I know positive 3 times positive 3 is 9, but I need it to add to -6, so I make them both negative. So, this is x times x minus 3 times x minus 3. Or if you want, you can write it as x times x minus 3 squared. So, same as before, you take each factor, set it equal to 0. So I have x equals 0 and x minus 3 equals 0. Which means I have two zeros, one actually at 0, and this has a multiplicity of 1, because x only occurs as a factor once. On the other hand, the x minus 3 equals 0 gives me a 0 of positive 3, and the multiplicity of this one is 2, because it occurs twice, and you can tell either by looking at the exponent here or just counting 1, 2, because x minus 3 occurs twice, so multiplicity is 2. Now this multiplicity is odd, which means the graph will cross at that position. Multiplicity of 2, that's even, so it bounces at that position. So let's actually go and graph this. X to the third minus 6x squared plus 9x. And let's look at the graph. There we go. I'm not sure I graphed that correctly. No, I did not. I still have a bit left over. I knew something was off here. Apparently I kept my old graph and didn't clear it out. So let me redo this. Minus 6x squared plus 9x, and okay, that's better. So at 0 here it crosses the x-axis, but at 3 here it bounces. So it touches the x-axis but then goes the other way. That's what I mean by bounce. Now we're going to do a couple more, but we're not going to factor on these. They are already factored for us. So it's the same process. You take each factor, set them equal to 0, and then solve. And that's how you get your zeros. So this one, I get -7. The multiplicity of this one is 2, because the exponent is 2, and because this is an even number, the graph bounces at that position. On this one, you subtract 1 from both sides, then divide by 2 to get -1/2. So that's my second 0, and the multiplicity of this one is 1, because 2x plus 1 only occurs once. No exponent means it's just an exponent of 1. And because this is an odd number, the graph crosses at that point. Now the last one, x minus 4, set that equal to 0 and solve, you get positive 4 with a multiplicity of 3. So the graph crosses at this location as well, because an odd multiplicity means it crosses. Same thing here. If you have the number out front, it still kind of counts, so we're going to take that equal to 0, that equals 0, and that equal to 0. So on this one, you divide off the 2, which gives you x squared equals 0, and then square root, you still get 0. Now the multiplicity of this one is 2. So multiplicity of 2. This is an even number, it bounces. For this one, solve, and you get -4. So -4 is my next 0. Multiplicity is 3, which is odd, so it crosses the x-axis at that location. And the last one, add 3 to both sides to get 3 for our last 0. And multiplicity is 1, so it crosses the location at that point. Now, one more thing, just to give you a little side note here. Your degree of your polynomial tells you the maximum number of real zeros a polynomial can have. So degree of 3 means the maximum number of zeros it can have is 3. We'll add up your multiplicities, we have 3. But this is true even here. Our degree is 3, and if I add my multiplicities, I get 3 again. Alright, so another practice problem, but this one's kind of going in reverse. I tell you what the zeros are and ask you to write the equation. So multiplicity, a 0 of 0 means if I were to set it equal to 0 and solve, I would get 0. So if I set x equal to 0 and solve, I'm going to get 0. So it's just going to be an x, but the multiplicity of it is 2, which means it's squared. Now, the 0 of 2 here means I'm going to have x minus 2 as the factor, because if I plug in a 2 here, 2 minus 2 gives me 0. Now, multiplicity of 2 means this is squared as well. Now, I'm going to rewrite this. This is x squared times x minus 2 times x minus 2. And I'm going to start by foiling. So I'm going to bring that over. So that's going to be x squared when I multiply here. Now this x squared is just this one. I rewrote it because I'm not using it yet. Then I have negative 2x and negative 2x, which gives me negative 4x. And then multiply here to get positive 4. And now I distribute the x squared to get my function x to the 4th minus 4x cubed plus 4x squared. So this polynomial has these zeros. Alright, that's it for this video. See you next time.